Now we are getting ready to start Unit 2. We have systems of equation. A system of equation involves two or more equations, and it can be linear or nonlinear. So a system of equation is two or more equations. When we are solving a system of equations, we are trying to find the input and the output values. So we need both that are the same to make all of the equations true. When these equations are graphed, the solution is where they intersect. So when graphing, it's where they intersect. X and Y, we want, let's rewrite this. I want to write it to where it says equal when we make them equal. It could be more than one time if the equations are not linear. So they could intersect more than once. In 8th grade, the focus was mainly solving the systems of equation. In Algebra 1, the focus is being able to actually write the system of equations from a word problem. Sometime asking for it, you're going to have to solve it afterwards. Systems of equation word problems. When writing equations for systems, the majority of them are going to be in standard form. Again, standard form is that ax plus by equals c. If a total is given in the problem, the equation will be written in standard form. So that's a key point to remember for you to be able to go back and reference. If you have a total, it's going to be in standard form. If the total is not given, then it will be written in slope-intercept form, and the y value will be the total. Okay? Steps so that you will be successful with your word problems. Step 1. What do you not know and what are you looking for? That's one thing you have to identify. Step 2. Assign variables to what you don't know and what you're looking for, and write them down. Okay, we're going to practice with that, making sure you write it down. Step 3, identify other information and numbers in the problem. See the quantities and their relationship instead of just the numbers. Common types of relationship equations with system word problems. You're normally going to be writing two relationships or equations in each word problem. Know these relationships and you will be able to write the majority of the system of equations. These relationships are both in standard form and slope-intercept form. So just because you think one's in standard form doesn't mean the other one's going to be in standard form. Standard form relationships. 1, 2 scenarios are given in the problem. So look at this example. Jesse bought 4 necklaces and 2 bracelets for $20. And Jackie bought 2 necklaces and 3 bracelets for $16. So X is going to be our number of necklaces because we're looking at standard form. AX plus BY equals C. X is the number of necklaces. Y is the number of bracelets. Notice it's written down. So we could say 4x plus 2y equals 20. And 2x plus 3y equals 16. Okay? Sorry, my papers are sticking together. Okay, 2 variables added to get a total. So the number of students, so this is another kind of example. The number of students and adult tickets was $125. We're still in standard form. AX plus BY equals C. We just don't have anything to do with the cost. Our variable, input and output, is X, the number of student tickets, Y, the number of adult tickets. Number equals total. Okay? Two variables number of times a rate to get a total. Tickets cost $3 per student, so it's going off just like what we were doing, except we don't want just the ticket number. We want more of the information. So the ticket costs $3 per student and $5 per adult. The total ticket sales was $322. Again, we had X is our number of student tickets, Y is our number of adult tickets. The cost of a student ticket is $3 per student, 3 times X. Per is going to mean to multiply. Okay? $5 per adult, 5 times Y, equals the total, $322. Basically, what you are going to be doing today is you are going to be setting up the equations. There were 34 student tickets sold and 17 adult tickets sold. The total ticket sales was $204. So in this situation, it changed, and the X is the cost per student ticket. So we know he sold 34, but our cost is X. So 34 times X plus 17 times Y is equal to 204. Here's an example where the rate is given in the problem, but the total is not. Plan A charges $11.25 per month, plus a one-time installation fee of $120. So X, the rate, $11.25 per month, that's our rate, but we don't know the total. So this is in slope-intercept form. 125 plus 125x plus the one-time fee. One-time fee is that constant, plus 120. Example 6 is a relationship between two variables. Pete sold 4 more than 2 times as many cars than Dan did. This is where it gets confusing. So Pete sold 4 more than 2 times. Set the variables equal to each other. X equals Y. Okay, so we have X equals Y. Then you're going to assign the Y variable to the variable with the larger value. So if he sold 4 more than 2 times the cars Dan did, that means Pete's was larger. So Pete's is going to be our Y. And our X is the number of cars Dan sold. So the Y variable has the larger value. Okay? So if we go back up here and look, the number of cars Dan sold is our Y. Pete sold 4 more, that's add 4, than 2 times. 2 times as many cars as Dan did. Well, how many did Dan sell? Y. So that's how we get 2. Sorry, I did that wrong. Y equals 2x. Okay? I thought about it correctly, but wrote it out wrong. So let's do some examples. Tim had 3 more toy cars than Beverly. So who's got the most? Tim's got the most. So Tim's is equal to 3 more, 3 plus Beverly's would be X. Terry made 5 less sales than Joe. So Terry made, let's just do what it has on the worksheet, Y. That's Terry, what he made. Joe is X, but his is equal to Joe's minus 5. Okay. Donna, who's our X, sold 3 more than 2 times as many as Jenny, Y. Sorry, this shouldn't be this way. We would set Donna as our Y. So Y sold 3 more, so we added 3, 2 times as many as Jenny, who is our X. 3 more than 2 times as many as Jenny. Bill has 3 less than 2.5 times as much money as Betty. So Bill has 3 less, minus 3, than 2.5 times as much money as Betty. So I'm going to put the minus 3 on the back end. Okay. Let's do another example. Chase and Sarah went to the candy store. Chase bought 5 pieces of fudge and 3 pieces of bubble gum for a total of $5.70. Sarah bought 2 pieces of fudge and 10 pieces of bubble gum for a total of $3.60. Write a system of equations to represent the scenario. Okay, first thing I have to think about is what are the 2 items we're talking about. We've got fudge. And we've got bubble gum. So I'm going to assign my X to be the fudge and my Y to be the bubble gum. So let's think about this. Chase bought 5 pieces of fudge and 3 pieces of bubble gum, and his total was $5.70. Sarah, that's Chase. Sarah bought 2 pieces of fudge plus 10 pieces of bubble gum, and her total was $3.60. So there is your system of equations. Okay, let's try this one. You read through it, try to answer it, and come back. Pause your video. The restaurant sold a total of 418 large and small hamburgers. So there's our 2 things we're talking about. The total hamburger sales, so the total was $1,077. Large were $3 and the smalls were $1.50. We want to write a system of equations. So I assigned X as my large hamburgers, Y as my small hamburgers. I know when I added both of those sales up, my total was 418 for the day. Okay, I know that the large hamburger costs $3 and the small hamburger costs $1.50. And my total sales for the day was $1,077. So here is your system of equations. I want you to try this one. All that will appear at the end is the answer. Here's your answer.